Do you know what ramen is? Ramen, yeah. Good, good. So let me introduce our next speaker, Jakub Kozlowski. He loves it. So he is open to your suggestions about the best ramen in Minsk. So feel free to address it. So let us continue. This is our last presentation for today evening for the Scala night. So please welcome Jakub Kozlowski.
So hello. I'm Jakub. I work at Okado Technology. I'm mostly doing things in Scala. I live and work in Wrocław. It's a beautiful city. You should totally visit. And I'd like to thank you for coming and thank the organizers for having me here. If you want to follow me with the slides, you can visit the link on the bottom. I recommend you do if you cannot see the code, but you should be able to see it. So today I'll be talking about HTTP4S and DOOBIE, two libraries from the type-level ecosystem that are really super cool, and I want to use them as well because they are so nice. And we're gonna also talk for a second about microservices and what they are and what problems they bring. So the first part of this talk will be the problem. There will be 4 parts, but I won't tell you the names of the rest because that would be a spoiler, kind of. So the first problem or problems, actually, this part is about the problems, but first, let's play a game. So all of you are sitting down. It's all right, but let's have a little movement. So let's play a game. It's called Never Have I Ever. If you're not familiar with the rules, it's basically I say a sentence like, never have I ever dropped a database in production. And if you've done this, you should stand up just to have a little movement. Is it all right? Cool. So, never have I ever used Spring in a project larger than Hello World. Nobody used Spring? Okay, fine. Yay! Okay, there's some movement. And please keep standing up until the end of the slide, okay? I want to make sure everyone is standing up at the end. So, and extra points if you are not, if you are ashamed of this. So, never have I ever added an annotation that required 3 more to work. Okay, no movement. Use play and try to upgrade it from some minor version. This one was probably the hardest because it changed like everything, how dependency injection worked, and you were no longer able to use global state and so on. Never have I ever cursed at dependency injection. Okay, almost everyone is standing up. I like that. Okay, you can sit down. These are just some of the horrors of frameworks, and just 2 frameworks on the slide. So now the second problem, microservices. But I'm not saying this is a problem in itself. It's just microservices have some problems that we're going to talk about. So before I tell you about the problems, it would be nice to have a definition, right? But I won't give you a precise definition because everyone understands it in a different way. But one that I found that was really close to the truth was that it's a set of architectural patterns for building distributed systems. And everyone who tries to implement this selects some parts of this set, not necessarily all of them. But the minimal set of properties that a system must have in order to be called, made of microservices is probably that they should be small. The applications that are the microservices should be small, like the name suggests. And small, it's not any specific number of lines or hours of work, but there's a general rule of thumb that you should be able to rewrite such a service in like 2 weeks, and certainly not a year. They should also be doing one thing well, so a service shouldn't be trying to do everything in your application, otherwise it's kind of missing the point. It should be autonomous, so an application should be able to function without the rest of the system being up, or the whole system should be able to function when some applications are not accessible. And perfectly, they should be isolated, so they should be deployed on different machines, or at least different virtual machines, so that if one is down, that doesn't affect the whole of it. And one thing that probably everyone who has done microservices will agree with me is that microservices are hard, because they bring a lot of challenges. So, why are microservices dangerous? First of all, there's lots of infrastructure needed. You need to be able to function in the world of microservices, you need to be able to deploy quickly and very often. You need to be able to react to failure. You need to have health checks and monitoring, logs, tracing, and all of that. You need a lot of setup. And also you need to be able to set up new applications quickly. You need to provision your apps quickly. So it's not cheap and it's not easy. Also, the network in the world that we're living in, it's not reliable. An HTTP request can fail at any point, and any communication between two applications can stop working. So that shouldn't influence the whole system, just the part that's involved in that. And you will be talking over the network, because otherwise it wouldn't be a very microservice way. Also, because now your applications are deployed differently, they have different JVMs and so on, you lose the ability to look at stack traces. They become useless. And then you need to employ some other tools that give you any possibility of understanding what's going on. For example, distributed tracing or aggregating logs in a single place with trace IDs and whatnot. And in general, they are challenging and quite complex about the idea and having different machines and whatnot. I can't stress this enough. It's hard, okay? And I'm not trying to discourage you. It's just the truth. And if you're trying to work with microservices, you need to evolve. Your team, your tools, your code, everything, all of that should evolve to keep up with the challenges. But it's not also so bad, not just dangerous, otherwise there would be no point in using them. Microservices can help you with a lot of things. If your organization is mature enough to do it well, to have good monitoring and so on, all that infrastructure, then they will help you with frequent and independent deployment. You'll be able to deploy a single application without having downtime in the whole system, just of that single app, and maybe even without any downtime. This will also happen much faster than deploying a monolith, because the application is much smaller, and that also is true for tests and CI and compilation times. Your system will can become more resilient, because if one part of the system fails, it just doesn't work, then that doesn't mean you're in big trouble. It doesn't always mean that. And also because your applications are deployed independently, they can also be scaled independently. So you don't need to scale the whole system if you want to support more traffic. You just need to you just need to scale the parts that receive the most load. And this is controversial, but if you're working within a single application, if you're not making a change to like all of the services, then it becomes much easier to work, because you actually don't need to care about the whole system, just some part of it, just some domain or two if you're building a feature into applications. And I can't stress this enough, it's hard, and there's a lot of things to keep in mind when you're doing microservices. This is just a web of concepts you need to understand, not all of them, but part of them. And probably the most important ones, if you want to have a good life and sleep in the night, is about the top right corner, the observability stack. So health checks, tracing, and so on. So that's the end of part one. We talked about the challenges and the problems. Now I'm going to talk about a solution to some of the problems, especially the framework problem. However, these slides may contain traces of Spring, so if you're allergic, please close your eyes or turn back. I'll tell you when you can look again. Okay. So the first thing that I want to talk about, the first pattern that's very pragmatic and object-oriented, dependency injection. So in frameworks like Play, dependency injection looks like this. You can inject things to the constructor, but surprise, you never actually call the constructor. It's the runtime doing that for you. And sorry, it's the framework doing that for you. However, you can customize dependency injection in Play, but it's still not a perfect solution. So what I propose instead of dependency injection through runtime reflection like here, I propose just passing arguments to functions. In this case, a constructor. How much simpler can they be? Now, beans, another concept from OO and Spring World. This is actually Spring, so don't look. We define a data source in this method. Let's pretend that it's that simple, like one line of code. And then we use that dependency, we use that data source as a dependency in another bean. So the runtime, again, will insert the appropriate values into our parameters. However, what if we want to, well, the data source, to create one, we probably need to make some side effects, right? So if you want to do if you want to do purely functional programming, this, by definition, by the types and by how beans work, this takes away your ability to stay in pure FP, because at the end of the world you need to, well, you have multiple ends of the world, like every bean is an end, and you only want one. So instead, what you can do in functional programming is just pass arguments to functions, right? And maybe use implicits in Scala, and maybe use resources that make your intent more clear. And this is really important with things like startup and shutdown hooks, this is again Play. If you want to do something when the application is shutting down, you want to clean up after yourself, you want to close connections, maybe some files, whatever, you need to register a lifecycle hook. So it looks like this. And again, it's not very functional because you need to do some side effects in the construction step. Here, I do it in the constructor. And then you need to do some more side effects in the stop hooks. And what is really bad about this is that you have absolutely no control over what order things are being closed with. Like, when does this hook get run? If you have many of them, then good luck trying to understand what closes first. But there's a better way in FP. You can make your resources, well, use the resource class from Cats-Effect, or there's probably something similar in ZO. So you can define how your resource should be acquired and closed at the start, basically when you create the resource. And then you can map on that resource to get a new resource out of that. We'll talk about that later. Another thing that's traditionally done in frameworks with annotations and all of that is scheduling jobs. So this is again Spring. And I use this annotation scheduled with a fixed rate, so every second I will have this job run. But what if I want to keep the result of each of these jobs as I go? What if I want to add some special error handling? What if I want to restart, like, with some... What if I want to have some state in this that will be used between usages of this job? And well, if you this is real. Like, if you want to add some error handling, like, okay, if there's an error, maybe try again in 2 seconds, and then in 4 and 8, and so on. If you want to do that, you can register a bean, like a task scheduler or something like that. But then you'll have to care about what's the scope of this bean, which jobs does it affect, and which jobs it doesn't. And because of the separation of, like, beans and the runtime and configuration, it becomes much less clear. But in FP, what you can do is use something like a stream. You don't have to. If you just care about scheduling and run, you can just use plain I/O. But with streams, you can do much more. You can accumulate the results. You can have some state between the jobs and do actually a lot more. So this is an FS2 stream that runs the job every 5 seconds. It counts the orders in the database and prints the amount. Yeah, I can show you a live demo later if you want. And another thing related to resources that I find problematic in frameworks like Spring is that if you want to limit the lifetime of a resource, it's well, weird at least. So here we have a controller. It's a singleton instance, so there's just one in the whole application. So that means, by definition of this, this constructor, that there's one user service. And the user service, yeah, let's pretend it is a singleton. But what if I want a new one at every request for some reason? The thing that might come to your mind is that, okay, let the runtime inject a new value every time I run it. So you move the user service from the constructor argument to the function argument. And because Spring is able to put arguments in your controller method calls, then that should work, right? Well, it turns out that it doesn't. It gives you a null pointer exception when you call the getUsers method. So it doesn't just fail in bootstrapping the application, or even better, at compile time. It just crashes it when you try to call it. And the way to fix it is bring back the constructor and add an annotation on the user service class, and set it to be scoped to a request. And if you forget the second parameter, you'll get something even better, an error message that doesn't tell you at all what you need to do. But it works. Now imagine you want to have a global user service in some places and a new one per request in some other places. I think that would be impossible. Or you would have to create a new proxy yourself. Crazy stuff. Now this is the change that's required in purely functional programming. Just 2 lines of change. Beautiful. So we go from a global user repository to 1 per each request. Of course, this is oversimplified because I still have a global one somewhere there in the module, but that would also work. So part 3, how functional programming fits into the problem of frameworks and of microservices. But first, let's define what FP is, because there are so many definitions. So for me and for a lot of my friends, the definition of functional programming is the lack of side effects. And a side effect is the lack of referential transparency, which was already mentioned today. And what RT is it basically means that if you have a program with some common parts, you can extract these parts to constants, and the behavior of your program will not change. This is a more formal definition, but let's look at the example. We have 2 x's in a tuple, and we have 2 a's in another tuple. And because x and a are the same, we can replace them. Well, these programs should be equivalent, and they are. However, how does it work in Scala? Pure expressions are referentially transparent. So this is pretty obvious that if you inline x, you get the right side, and the programs are the same. You'll get to freeze in tuples, right? However, the moment you start doing side effects, you lose that property. Because now, if we have x equals readline, we will immediately be asked for some input, and that input will be used twice in the left side, 2 x's. However, if we inline x to become to build a tuple of 2 readlines, we will be asked for input twice, and the result will be, in most cases, like the vast majority of cases, it will be different. And the same goes for future. Future is just like a side effect, except that it's asynchronous, right? So here we don't even have the guarantee that, okay, in this case we actually do, but basically when you create a future, it's already running, and you cannot start it again. So the left side here will be run once. On the left side, the readline will be run once, and on the right side, it will be run twice. So is there a better way? And there's I/O. Our Lord and Savior I/O. So I/O is a type, it's a purely functional data structure that allows you to suspend side effects. And thanks to that, we can actually benefit from that property of referential transparency. Because if we save a read line in an I/O to an X, and we use that X twice, it will be run twice. And if we inline the X, it will be the same. So that's the definition of purely functional programming with effects. And here's a reminder of what that is. So, 1 sec for water. And you can look at this slide while I drink. So I showed you resource before, but here's a more specific example about resource and not just types of it. Is it clear? So resource is a data type in Cat's effect that allows you to define how a resource can be acquired and cleaned up. And you can compose such resources together. I think it's small. I think it's too small. Okay, so, and if you compose such resources together, they will, well, you can build new resources out of resources and so on. But the best way to explain it is probably an example. So I'm sure you cannot see that one. Okay. So I define a function called lock. It will allocate a fake lock. It will say that we are allocating this lock, and when we are closing the resource, it will just say releasing this lock, okay? And there's another one called file that will take a file name, allocate a file reader or file reader, and then clean it up when, well, close the file reader when it's time to clean up. But the important part is that we have this mega resource here. So we flat map on one resource and to another resource and yet another one. And we build a new resource out of that. So we will have a resource that still contains the file reader, but on the way to acquisition of the reader, it will also make build these two locks, okay? So we use that and we read the lines from that file reader, and then we print finished reading lines. So the curious part about this is that the acquisition happens in the order that we defined it, but the releases, the cleanup happens in the opposite. So the one that we acquired last will be cleaned up first, because it could have depended on something else. So this is the only reasonable order of that. And it's really cool. It's really composable and really cool. So part 4, in which we talk about the actual libraries. So HTTP4S is a functional interface for HTTP in Scala. It supports there's both a server and a client. It supports multiple backends. So there's a backend for Blaze, which is the one that HTTP4S developers are making. It's very fast, but if you are not satisfied with it, you can use Jetty or Tomcat if you're living in the 90s. And it's built on FS2, which we already saw, the streaming library, and Cat's effect, so a library for effectful programs. And it's resource safe. It provides you, the resources that it provides are using this resource class or streams, so that when you create a server and you use it, and when you're done using it, it will be closed, it will be cleaned up. Because probably everyone here has had a case when they had leaked some resources, like a server. If you want to have a way to restart your application, for example, in development, you need to either kill the JVM or make sure that everything has been closed cleanly in the machine. And the faster way is probably the latter. So the core building block of HTTP4S for users is the root or HTTP roots type. It's how you handle a request and how you make it a response. Except it's not that simple. It's not just a function from request to response. It's a function from request to I/O of response, because you might want to have some effects in the handler, right? But wait, there's more. There's actually an option in there, because not every root will match every request. So if you don't match a request, you need to return a none here. And there's even more, because the request and the response contain bodies, which are streams of bytes. The streams are parameterized with an effect type, and that is, in this case, I/O. And it's slightly more complex if you don't know some more advanced functional data structures. There's also CLIC and option T involved. So CLIC is just an effectful function, and option T is just a monotransformer with an option inside it. So all of these things make it possible to compose routes in functional ways. You can even map on a route if you want. And in real life, they are also parameterized with the effect type, so we get F everywhere. Here's a cheat sheet if you want to look at it in the future. So, what about it? What's so nice about it? Well, a route is just a function. And if we have a function, imagine we wanted to build a middleware layer. So we want to make some changes to the routes that someone gave us. So we can do this, because a route is just a function, so we can modify its input and output. We can inspect the output or the input. We can do things with it. So we are able to customize the behavior of our application in a very generic way. Here's an example. This is from HTTP4S. They provide a middleware for timing the response. So it takes any route. In fact, okay, HTTP app is like routes without the option. It always matches, okay? So it allows you to wrap an existing HTTP app and add timing capabilities to it. So it will add a header with the time that it took to process the response, the request. And there's some built-in server middleware in HTTP4S. There's like 20 implementations. Some of them are really useful for the microservice age. For example, metrics, the request response logger, the throttle if you want to do some rate limiting, the timeout, and so on. But I only talked about servers for now. Let's talk about clients. And the client is also a function, pretty much. You can build a client from a function from request to resource of response. And when that resource has been consumed, it's being closed, the HTTP connection underneath will be closed. Yeah, it's just another function. And because that is also a function, there's also middleware for it. So there's built-in middleware for like metrics, retries, and a few more. And you can, of course, build your own. And there's also another nice thing about the types here. Because a server and the client are just functions, you can create a client from a root. So if you create a mock server using that, if you define just how the server should behave when it gets a request, you can create a client out of that will make no connections, no HTTP calls, and it will just work in memory and will give you the results that you provided here, which is, I think, pretty cool, because you don't have to set up mock servers and so on. And it's very fast. It's very fast because it's just calling a function. If you call an endpoint in test, an endpoint like the one on the previous slide, it's just a function call, and there's no resources allocated to this. And it works very well. Now DOOBIE is a functional JDBC layer. So it provides a functional interface for talking with databases. It's built on FS2 as well, and CAS-effect. And it's, again, resource safe and supports streaming, which is a hint that we might be using both in a second. And there's no reflection or magic. If you've ever worked with like Spring Data, then you probably know that Spring Data, how it works, you write an interface and define some methods without implementations, like find top 10 users by something, and it will generate the implementation of that by the method name in runtime, which is magic, and it's impossible to debug. And maybe you've worked with Slick and had a case when the code compiled, but the SQL that Slick generated was not valid or didn't work like you wanted it to. Then if you've had these experiences, you want to write raw SQL. So this is what you can do. So So to execute a query with DOOBIE, you need a transactor. So this is the type, the data type that changes a query more or less to an IO. And because it's a resource, in this case, it's a resource because we are allocating a connection pool upfront. But there's also a variant of transactor that works just like that without any resources. So I mentioned queries. So this is how you write a query. You just use the SQL interpolator. They are not validated at compile time, like not at all. The only thing that's compile safe is how you insert an argument, like the ID here. This will be this will be entered into the query in a way that SQL injections are impossible and so on. And also the query country part, it will basically make sure that the compiler, or sorry, that Scala can convert the columns that you select to a country, but it won't validate like the amount of columns that you select. It will just make sure that it can convert JDBC results set to a country. Okay, here's another query, and notice that it's just a val. It's not like, it doesn't have any effect creating a query, okay? And we're gonna use this in a sec. Here's an example of how you use a query. We pass a parameter to it, and let's say we want we want to select one field. Okay, sorry, one row. If there are any more matching, this will fail. But if there's just one with that ID, we will have a sum with country inside. And here's how we stream from a query. We just use .stream, and now we have a stream. And to convert the connection IO, so the result of what we just did, to an IO, so to make it, actual database calls, you need to use the transact method, and you need to pass a transactor. So here's how we might use it with the transactor resource. We just say use, and we call transact, and then we print that to the standard output. And it works the same with a stream. So if country 1 is a stream of connection IOs, you also do just transact, and it turns it into a stream of IOs. Here's an example with HTTP4S. So it's probably also small. So in this application, we basically provide one endpoint in which we show one endpoint in which we will stream countries from the database using this query, and make a transact call, map that to JSON, and voila, we have made a response. So notice that we are building our resource out of a transactor and the server that also uses the transactor. So when we are done using application, which means never, or if our application terminates with an error or gets shut down, this will be closed first and this next. Okay, and there's also one cool thing about DOOBIE. I mentioned that it doesn't validate anything at compile time, but it provides a way to check your queries with the database if you have a connection. So in tests, you might want to test your queries like that. And it will not only tell you if you use the right amount if you select the right amount of columns for the query, it will also tell you if you use the right Scala type. So for example, if you have a big integer in the database and you try to fit that into an int, it will not pass the test, or it will with warnings or something like that. But it will give you a very detailed report of what went wrong. So our time is up. If you want to look at the slides, they are here. The code was mostly all compiled, so you can look at it as well. And now it's time for questions. So what's the first question? Don't be shy.
Raise your hands. Yeah.
Hello. Thank you for your talk.
Thank you.
Have you tried raw or any other kind of documentation for your HTTPS?
Sorry?
Have you ever tried raw?
I haven't.
What kind of documentation do you use for your services?
Yeah, so for documentation, I just write Swagger myself.
Any kind of, do you prefer any format for your documentation, or like?
I mean, you're asking if you can generate documentation from the roots?
Yeah, it would be nice.
Yeah, so there are some tools like that. There's a new one called Tapir from Software Mill that's supposed to work with, well, you define your endpoints in their DSL, and then you can convert that to a documentation and to a server. So that's one solution. There's also endpoints, and I think there's guardrail from some company, I don't remember the name. But basically, it's supposed to work like that. But I haven't tried Row. I think it serves the same purpose, but I think it's also incomplete. Like, it doesn't allow you to specify in the types what the response of a request will be.
Mm-hmm.
Yeah.
Thank you.
Okay. So for those who don't know, Row is just a DSL, another DSL for creating HTTP routes in HTTP4S. Any other questions? Okay, so if you're shy or you don't have any questions yet, you can ask them later on Gitter, or write me an email, or write on Twitter. Please read my blog and enjoy the rest of the conference. Thank you.